So the computation just goes as discussed. We for each row in the rows of A, 5 for each 6, and we collect the contribution from the DB for range 3, for Q in range 3, and the contribution of A, I, J. Okay, we give it as this will be DB padded I plus P, G plus Q, and this will be multiplied by the kernel, but now the kernel is flipped, so we will compute that as 3 2 minus P and 2 minus Q. Let's check. Yes, exactly. So actually, I believe that here you can use minus P and minus negative P, negative Q. But let's just take the safe and safe way. Keep it simple. Here, okay. This is our computation, and this is the analytical solution of how the element in A will affect the objective function of L. We can verify that, of course, using the same way. Okay. But now we will need okay, the A numerical is the same as DB. This is 5, this is 6. Okay. Okay. But here we need to recalculate the B. AIG, okay, AIG, LA. Okay. So we need to define LA. In the LA, we need to compute LB, compute another B, and a new B, and use a new B to compute the objective function of L. So to clarify, we just copy the entire computation down here. Let us. I want to remove those square, which makes things a bit more complicated. So A, and we will define a convolution, our convolution of maybe, let's see, X and kernel to be the same implementation we have done above. Of course, this is a very creepy implementation. Sorry, should be this way. because we shouldn't just specify the size. We need to calculate the size dynamically. But let's say just for now, we prepare the convolution here, and this I just to avoid has to be 0, and let's use this. This is the input x I pay j and q times kernel, sorry, pay and q. So the output I and j is s. Okay, now we have redown of kernel a. Okay, now we will compute b using the defined convolution here, convolution a, and the kernel. The kernel is the global kernel outside, which is not a good habit of computing that, but just here. Okay, so let me recompute the dB here to have a fresh start of dB. Okay, now the dB is a correct value. Okay, and L is the value we want to have. So now LA and this new A, and let DANIG is this, and let AIG to be the same as the original. Okay, let's finally check that. Okay. Oh, error. Oh, I forgot to return. Right. Again. Okay. It seems that I forgot to refresh the the dB that is used to that we have calculated for the for how B affect the output of L after we have experimented with those squared function before, and after we have computed this, refresh dB, and let's do that again. Fine, this looks right. Using the analytical method to compute dA, we have arrived at the analytical answer of this. So that means element wisely changing the element of A will affect the objective function in this way, and this is a numerical verification. Well, actually, you will find that this is just another convolution. So we can actually use our convolution function to compute this as well. However, this will need to change this convolution function in a way that it can accept all sizes of the impedance kernels. You can try it back home.